Hello, this is Vinay, and I'm going to be talking about ciphers. So ciphers are basically codes that people use to decode messages whenever they wanted to, send secret messages for any sort of reason. People in like the old days, like if you see history documentaries, people use like ciphers in order to decode their messages, and later on, and people that they trust have encoders that basically encodes the cipher and they can read the message. Basically, I'm gonna go over two sort of ciphers, and I'm going to implement them in Java, and you'll see that in a second. And the two of them I'm gonna go over is sort of easier, is really easy, but it takes a while to decode. So the first one I'm gonna do is a Caesar shift and an Atbash cipher. So let's over and go over with the Caesar shift. So basically, you'll have A, B, C, and they might line up with the certain other letters like Q, R, S. So if you have 1 second, let me open my thing, notepad, and then if you have A, that would be equal to B. Right? Let's say that would happen, right? Then B will be equal to C. Then D will be equal to E. Oh yeah, C would be equal to D, and then D would be equal to E. So basically what that does, this shifts the letter to a certain position based on the other letter given. And so that's essentially the cipher. And so if I have like the if I have the word apple and I shifted to B, this would be B, this would be Q, Q, M, F. This would be the decode. And we can actually test it here. This one's a little different because this one runs on numbers, not on letters. So if we do 1, type an apple, you get the same thing here. So that's what I'm going to try to implementing. And like I said before, we're not going to be using numbers, but we're going to be using like actual characters. So how are you going to implement this in Java? So it's sort of simple. So are you supposed to use it? No. Okay, it's sort of simple. Oh. Sort of simple. So what we're going to do is we're going to get the ASCII code. We're going to use ASCII. What ASCII is, it's basically a table of numbers. Here, I'll show you. It's basically a number that represents a specific character. So here's a really good image of it. I have one downloaded, which probably would be better. There you go. So each character represents a decimal number, which we can use that to find a specific ASCII code. What we're going to do, if we have A and it goes to B, right, we're going to add the ASCII code of that actual character, and then to encode it. And then for decoding, we already have the decoded message, so we just subtract the ASCII code. So I'll give you an example. So we have A, right? It has to be shifted to B. So A's ASCII code is 65, and B's ASCII code is 66. What we're going to do is we're going to add 65 plus 66. 65 plus 66. And then to decode, we're going to take this and subtract it by 66, because this will already be the encoded character, right? So what we would do is we would add these together and we would subtract it by the shift character. And that's essentially how it will work. And the way we're going to give it is we're going to have a message. We're going to have a method, and we're going to call it encode. And we're going to parse in a string, message, and we're gonna have pass in a char shift, and then for the decode we'll have the same thing with the same parameters, and we would basically copy both the methods and then just change this operator. And we don't have to do this because that's basically the character that's given. So I can just replace this with character. And then so that's how it will work. So let's go ahead and test it. So I'm gonna go open Eclipse. I'm going to close this because I've already done most of this. Changes done. And new Java project. YouTube. Sorry if you hear too much noise. I have parents who yell at each other a lot, so yeah. So I'm not gonna worry about a package. I can just not quickly put a package right now because I can't do it with no package. And then I'm gonna go ahead and put Caesar. Main method, and then we're done. So let's go ahead and implement the two methods. So private static void encode string msg, and then char shift. So I'm going, oh whoops, we need to return a string, right? And I'm going to go ahead and have string result. Okay, so now I got this right. We're gonna go ahead and cycle through every single we're gonna cycle through every single character in this variable, in this string. And the way we're gonna do this, we're gonna use an advanced for loop. We're just gonna type in char c colon and then msg.to char array. And basically what we're going to do is we're going to do result plus is equal to, we need to get the integer value of it, so we need to go int c or no, I just have to add the characters together, don't I? So if I put like these, so if I put these brackets and I put c plus shift, and now I add the quotations here to convert it to a string, then this should work. And now I just return result. So let's test it. Encode. So what are the one we worked with, right? We used A, B. Let's encode apple with B. Whoops. B. Come on. B. No, run it. I know why. We need to convert this integer to a character, because when we add two characters together, the operator like sort of assumes that it sort of makes it so that the character is actually an integer, and that integer is based on its ASCII value. So now that we got character, now it should return this message. Now it isn't exactly the same, but it's like, because we're using ASCII codes, not exactly the shift code, so it's a little bit different. But if we try to write the decode method now, and we'll go subtract the shift. Now we copy this. And paste this here. Now we return apple. So that sort of shows that it works. Now I can go ahead and change any of this to whatever I want. So if I go column select any of these characters. Let's say I want it to be F. It will return. This will be different, of course. So I have to remove this. And I can paste it here. You know, in fact, I can just have this in line if I wanted to. So I can just copy this, paste this in here. That way I won't have to deal with like keep on running it. And then it should always return. It should always return Apple as long as I change both these characters. So if I just set to 8, it will return Apple. And basically any character, and I can even choose like an ASCII character, and it should be able to work. So that's basically the Caesar shift, but it's not exactly Caesar shift because we're using ASCII, but it doesn't really matter. This sort of works, and this is a pretty good way to basically decrypt your code. So now let's go ahead and do another one, another cipher. So the next one we're doing is Atbash, and the way it works is if you have A, it turns to Z. If you have B, it turns to Y. So basically, if I have A, it turns to Z. If it turns to B, it turns to Y. Basically, A, B, C is Z, Y, X. So it's sort of backwards. So you guys get the idea. And for this one, we're only going to work with uppercase because it'll be easier if you have that with ASCII. So ABC would always equal ZYX. So that's what we're going to do, but we could do it differently. But I think, you know what, let's just stick with uppercase letters because it'll be easier. So we have our ASCII table, if I can pull it up. And we have 65 is 90, basically. If you have 65, it turns to 90. And if you have 66, it turns to 89. But how are we going to do that? Are we going to literally type in 65 is equal to 90 and 66 is equal to 89? No. What we're going to do is we're actually going to have a slope-intercept form equation. And the way slope-intercept form equation is equal to y is equal to mx plus b. Sort of linear of what you have. So that will basically create an equation where if we type in the input as any of the ASCII numbers, it returns basically any of the other ASCII numbers, sort of. So basically, what will work is if we turn in 65, it'll turn in 90. If we turn in 66, it'll turn in 89, and so on and so forth until it reaches like the middle point. And that's how basically it would work. And so let's go ahead and test this. And what I'm going to do is I'm going to actually quickly find a slope-intercept form creator. And here we go. So now let's go ahead and type in our value. So if 65 is equal to 90, 66 is equal to 89. You should return equals to y is equal to negative 1x plus 155. And we do. So this would be our equation. So if we typed in typed in any ASCII from 65 to 90, it will return another character from 65 to 90. If we don't, then it's probably gonna crash. It's probably not gonna come out right. But that's fine. So let's go ahead and copy this. Or I'll leave it here and then I'll copy it later. Now let's go ahead and come here, and I'm literally just going to go ahead and copy this class and call it Atbash cipher. Now I'm gonna leave this here, and let's go and see how we're going to do this. Let me go. So Atbash. Atbash cipher. So we're gonna have. So basically, like I said, it goes from A is equal to Z, and B would equal to Y. So that's how it works, right? And basically, all we did, we created a slope-intercept form equation that basically said if A, basically, it's if you get the value, returns what the range of it. A to Z and B equal to Y. Using these 2 points, you're able to find a slope-intercept form equation, which was this. Don't they have like any format better? No, it's fine. Leave it, and then I'll bump this. So that's the equation. So if we type, so we can go ahead and test it by going, okay, so A is 65. So negative 65 plus 155 is 90. It's 90 is equal to Z. 90 is equal to Z. So you sort of get how it is. And I can type in B and it'll return Y. And that is essentially how we're gonna work. And it's basically gonna get the ASCII and put it in the slope intercept form equation. I think a lot of you are lost, but you'll see how this will work. And so if I go back to my Eclipse, let me quickly go over how the methods are gonna work. So we're gonna have string encode, which is just going to take a string MSG and same for decode. So I'm going to go remove this and I'm going to rewrite this completely and then remove all of, this is, and basically what I'm going to do is I'm going to do result plus, actually for this one I don't actually need a decode, I'm assuming. Because they're both be the same exact thing. So what I'll remove the decode because I don't really need the encode. Because the encode, if you do it both ways, then the encode stays the same. So, yeah. So basically, I would do result plus equal to C. And we basically need a slope and intercept form equation though. So I'm going to copy the right side of this equation. I'm going to turn this times C. I'm going to basically put this whole thing in brackets. And then convert this into a character. And then just to make sure it be okay, I'm gonna add quotations. There we go. So if I now print this out and code, and I can only do uppercase for this. Type in hello, it should return like spool or something. Yeah, and we can go ahead and test this. If I go up here, Atbash cipher, hello. So there's how it works, and those are the two ciphers. If you want me to do more videos, just tell me in the comments below. You probably aren't gonna comment because I barely have any subscribers. Yeah, that's very sad. But anyway, thank you for watching, and I'll see you later. Bye.